Hello, today we will be discussing the RSA algorithm. If you want to know more about what is RSA algorithm, where is it used, and so on, hit me up with a like and a subscribe and I will make more videos on this. But for now, let's get directly into the RSA algorithm. First, step number 1, we need to choose two variables, P and Q. In original or real-life cases, P and Q are very large values, but for computational case scenarios, let us choose simple values. So, P is equal to 3 and Q is equal to 11. Step number 2, we have to compute N. N is equal to P into Q, which is simply nothing but the value of P multiplied by the value of Q, which in our case is 3 into 11, which is equal to 33. And Z is equal to P minus 1 into Q minus 1. P minus 1 means 3 minus 1, which is 2. And Q minus 1 means 11 minus 1, which is 10. So 2 into 10 is equal to 20. Now, this is an important step. We need to select E such that E is greater than 1 but less than Z. And E and Z are relatively prime. What does the term relatively prime mean? It means that the GCD of E and Z is equal to 1. We have to find such a prime that it does not divide Z. For example, if we did 20 divided by 3, we would get a non-integer value. So that means we can use 3 for our E value. Could we have used 5? No, we could not, because 20 divided by 5 is equal to a 4, which is an integer value. That means the remainder is 0. It's completely divisible, so we cannot use 5. For our example, let us stick with E is equal to 7. Now we need to find another variable, D. D, using the formula Z into Y plus 1 divided by E. Z is the value we just calculated, and Y I will get into this later, and E is the value calculated from step number 3. 20, because Z is 20, into 1 I will get into Y, this is 1 later, plus 1 divided by 7, which is the value of E, is equal to 3. Now, Y can be values ranging from 1 to 3. What we do is, in this formula, we keep on substituting Y with 1, 2, 3, 4, and so on sequentially until we get an integer value. In this case, we were lucky that in the first case, in the first number, we got the value, so it's equal to 3. Now we were basically done. The final step of the algorithm says that the public key is equal to En. E is 7, N is equal to 33, and the private key is D and N, which is 3 and 33, which we have calculated above. So if you want to know more about how to implement or how to encrypt and decrypt using this algorithm, please follow for my next video. Thank you.